Assalamualaikum and good day everyone. So today we are going to proceed with our topic 5, and in this topic we are going to discuss on the counter function block in the PLC programming. A PLC counter is a function block that will count up and down until it reaches certain limit. So when the limit is reached, the output of that rung is set. The thing is that counting is in fact widely used in PLC programming, and often you will have the need to count different things. For example, this could be to keep track of how many times a process has been completed or how many products has been produced. With all that said, counter is very crucial in every PLC programmer. Okay, to know the basic of counting in a PLC program. So in this topic, I will explain to you how counter works and how you can use them in your PLC programs later. So these are the contents of our topic. So I will go one by one. So as I said just now, counter allows a number of occurrences of input signals to be counted. When the input to the counter is true, then the counter will start count up or down according to your design specification. And then a counter is a PLC instruction that either is going to be incremented or decremented. And then it is actually an integer value that is prompted by the instruction or that is activated by the input signal of bit from 0 to 1 true. So it will start counting when the trigger is in low high condition. Low and high condition. In the timing diagram, so when the signal is changing from low to high from this trigger input, then the counter will be started its counting. So every time the run condition or the trigger, okay, the run condition of the trigger of the counter is changing from false to true, a count up instruction in the run is going to increase its value by 1, and if you are using a countdown counter, it will decrease its value by 1. A counter retains its accumulate value when its run condition is true, false, or changing from true to false. A counter's accumulate value can be reset to 0, okay, by using a reset instruction that you can actually put it in your counter. So when you give a reset value to the counter, then this reset instruction will put the value of the counter back to its initial value. So now we look one of the example of the application of the counter in the PLC programming. So imagine this is an automation system that you have. You need to count the number of boxes that pass along the conveyor belt. So when this number of boxes pass over some specific number, for example, maybe you need 15 boxes to pass through this route. Okay, so when it reach 15, then the next box will be diverted to a different route. So this is one example. So in order for you to keep track of these 15 boxes, then you need a counter to count the box. So there are 3 types of counter that are used in PLC programming. We have count up, count down, and count up and down. This is a combination of up and down. So in order for us to differentiate the types of this counter, we just need to differentiate the value of an input, which is the direction of the counter. Either it is going to be up or down. So later you are going to see it clearly in our demo. So the counter will be executed when the change of input from 0 to 1. This is the rising edge of the signal from 0 to 1. So when the trigger value is changing from 0 to 1, or during this rising edge, and then the counter will start count, either count up or count down. And then the counter limits are normally 0 to 999. So this counter can be found in the address of some address in the PLC. For example, in S7 300, there are 64 counters that are available in this PLC, which is addressed from C0 to C63. Now we look into the basic functions of counter. We have CU to increment the value by 1, and then we have CD, count down which will decrement the value by 1. And then it will be not decremented if the value reach lower limit. For example, 0 here. And then S is the set value that when it change from 0 to 1, the counter will start the counting process. Okay, so this is the set value. And then R is the reset value. So when the counter is reset, then it will be set to its initial value. Okay, either to the value that it has been set or to the value of 0. Later, when you see the example, then you will see it clearly, this reset button. And then another additional functions at the counter is PV. This is the preset value, meaning that you set the counter value at certain limit. So it can be set from 0 to 999, or you can use input word or output word, okay, or memory word or data word. So these are the value that can be used to set this PV value. So we also have a counter status, which is Q. So Q is 0 when the count value is 0, and Q is 1 when the count value is greater than 1. So the number of the counter value, it can be either in binary number or binary coded decimal number. Okay, so the current value can be in binary or BCD number. So now we look into the detail of the counter block here. So we have CU, counter up, CD, counter down, set, this is counter value or preset value. And then this is a reset button, and this is the either binary or BCD output, and this is the counter status. Count up and count down value will start counting when the set value is changing from low to high. And then they will count until it reaches certain limit. So this limit, you can set it in the PLC later. And then on the output of this counter, the value of the counting value, it can be either in binary or BCD. So binary number is in the series of 0 and 1. And then BCD, it has first, second, third digit. Okay, so this is BCD. BCD is from 0 to 9. And then this is the status of the counter, either 1 or 0. If the counter value is greater than 0, it will give the value of 1. And if the counter value is equal to 0, it will give the value of 0. Let us see the timing diagram of the counter. So let's say this is this input signal for counting up, and then this input signal for counting down. So meaning that you set your counter at this time for up, and then you set your counter at this certain time for down. Okay, so this is the set value. Okay, and then this is the reset value, and C10. 10 is the value which currently you set the value to 5 here. So when the input of counting up is triggered here, the count value will start count here. Okay, and then it will remain until it find another low to high signal or another rising edge of counting up, and then it will add 1 to the current value of the counter, and then it find another one here, then it will add 1 again. Okay, until it reach the set value here, the counter preset value here, which is 5. So the output will turn on because it has reached its limit 5. Okay, it will be keep turning on because the counting is already reached 5, and when it reach greater than 5, it will keep turning on until you put a reset signal here. So when you put a reset signal here, and then the counter will stop the value. Okay, it will stop the value. When you set a value set here, so this counter is going to be loaded with its preset value, which is 5. And then it will start counting down because right now the counting down is activated. So when it finds the rising edge of this counting down value, it will decrement by 1, minus 1. Okay, for counting up it will plus 1. And then when it finds the next rising edge of counting down signal, it keep decremented by 1. Okay, and so on. Right? So this is the timing diagram of counter. So when we do the example, you can see this one clearly. So now, let us do this exercise. Right now, the counter is not set to its preset value. So meaning that this counter will be started from 0 here. We started here. And then when the counting up, okay, because this address is counting up, this is counting down, this is the set value, and this is the reset value. So when the address of counting up is activated by this impulse of counting up signal, okay, you can see this is the rising edge of this signal, and then it will add 1 to the counter value. And then it will remain 1 here until it finds the next rising edge of this counter up. So it will add 1 to the counter value. And then it will remain until it finds the next one here, add up, and then remain again until here. Okay. At this value, you see that this counter has been set. So it will be set to its preset value here. So the preset value here is 5. So it will go to 5. Even though you still have counting up value. Okay, or you still have the counting up signal here. So it will be set here. When it reaches 5, so the output will be turned on. Okay? Right now, you reset this counter. So the output will be turned off. And then this counter value will be turned off. So there will be no value here. Okay? And then when you set it back to here, so it will be set to its preset value of 5. And it will remain until until it has found another counter up or counter down trigger value. So in this case, it just find this counter down trigger value, which is this low to high, the rising edge of this counter down value. So it will decrement the accumulated value by 1. Okay, and then it will remain at this value until it find another counter down value. But at this point, you reset this value. And then here, as you reset this value, but here because the value is 0 now, so when it finds the next counter down, it will reach the limit 0. It cannot go beyond below than 0. So it will remain 0. And now here, it finds the next counter up, rising edge of the counter up, so it will increment 1 here. Okay, and then at this point, it receives the counting down, and then it will go back to 0. And then it will remain 0. At this point, the set value is set. So it will go back to the counter value. So it will go back to 5. And remain until it finds the next counting trigger input, which is counting down. So it will decrease by 1. Okay. and then this one meet another counting down, so it will decrease by 1, and then remain here, and then it will increase by 1 because counting up here is activated, so it will increase by 1 here, and then remain, and then increase by 1, and then you reset this counter, so it will reset to 0. So this is the timing diagram of the overall process of counting up and counting down counter, okay, with the input of reset and set. Okay, but don't forget the counter output here. So when it reach 5, so it will be turned on here. Okay, this is when it reach 5. Every time it reach 5, it will be turned on. So here and here. Okay, because in this diagram, when the counter reach the preset value, it will be turned on. And then when it reach 0 or less than this preset value, it will be turned off. So this is how we create the timing diagram of the counters. So hopefully you can digest the information, and then you can retry it. Okay. Now we move to the logo simulation of this counter up and down. So in the description, it says that an input pulse increments or decrements an internal value depending on the parameter setting. So parameter setting is either off function, on function. So this is the Q, the output during off function and on function, and then the preset value. Okay, preset value meaning that the counter value. Okay, so this is the limit. You put the limit of your counter. So the output is set or reset when a configured threshold is reached. So this is the threshold value or the limit. Okay. The direction of the count, it can be either up or down by changing the signal at input direction here. So if the direction is 0, so meaning that it will count up. If direction is 1, it will count down. Okay, let us see the timing diagram. So count, okay, is the trigger value that you give to the counter. So when the value is changing from 0 to 1, or when you see the rising edge here, so it will start the counting. Okay, so to do whether counting up or counting down, it will first look at the direction of the counter. So if the direction is 0, so meaning that at this certain time, it is going to count up. Okay, if the direction is 1, at this specific time, it will be counting down, and so on. So it will when it sees the input trigger has been activated, and then it will see the direction of this counter. So at this moment, the direction is up, so it will increase by 1 every time it sees the trigger input here in the rising edge mode. Okay, it will be increased by 1 until it meet with the rising edge of the down counter, which is the direction 0. So when the down counter is activated, it will be decremented. Okay, the current value of the counter will be decremented by 1. And so on. Alright. So in this stage, the counting up is activated, so it will be incremented by 1. Okay, until you reset the counter. So when you reset the counter, it will be reset back to square 1 here. Okay, and then after the reset input signal, it will start counting up because the input direction here is 0. Okay, since you put the threshold value of 5, okay, so if the value is greater than 5, it will be turned on. If the value is less than 5, it will be turned off. Also meaning that the Q output here is when the value is 5 and beyond 5, it will be turned on. So until the value is decremented below than 5, so it will be turned off. Okay, and then it will reach on back when the value is 5 and above. Okay, and then will be turned off when the value is less than 5, and so on. Okay, so this is the timing diagram of logo counter. This is the parameters that used in the logo simulation. R is for the reset. Count is count is a trigger input, okay, for counting up or counting down. Direction will determine this counter either for counting up or counting down. And then parameter is the value for on or off threshold and the start value. Okay, so meaning that you start the initial value of this counter start at certain number. And then output is the output, it will be set according to this parameter value. Now I will show you the simulation of the counter by using logo simulation. So in this simulation, I will show you how to simulate counter up, down, and the combination of up and down counter. To choose this counter function block, you can choose it in the special function. Okay, so under counter section, you can use this up, down counter. Okay, so when you put it here, so it has this value R, and then this is the count signal, and this is the direction, and then this is the parameter. So this parameter, you can set it by click on the right click. Okay, and then you can put the block name as up counter, and then in this example, I will start the value from 0, so it will start count from 0, and then the output will be turned on when the value reach 5 and above, and then it will be it will be turned on when the value is reached 5 and above. Okay, so we start the simulation. So now the current value of the counter is 0. Okay, so this is I1 is the reset, I2, I3, and this is the output of the counter. So this output will be true when the threshold value at this counter is passed. Okay, so for you to start count, you need to give trigger input to the counter, which is at this CNT signal. So this is I2. So whenever you give input trigger to the counter, it will increase the value of the accumulated value in this counter by 1. Okay, and then you give another signal, so it will be added to 2, and then until it reach its threshold value. So 5 is the threshold value, so meaning that the counter has been turned on. Okay, so whenever the value is greater than 5, it will be turned on. Alright, this is counter up. Now we move to counter down. So to do counting down, so you still need to use the same up and down counter block function block here. Okay, it's just that you need to set this value to down. Okay, and then maybe you want to start count from 5. So meaning that it will be decreased from 5, and then it will be turned on when the value reach 0. Okay. So please bear in your mind that this is the threshold value for the Q to be turned on or off. So it will be turned on if the value is 0, and then it will be turned off when the value is not 0. Okay, meaning that you are given 1 to what other value, but it is not 0. So you will give the counting down trigger here. But now the direction of the count input here is 1. Okay, whereby in this counter up, you need to give direction of 0. So if you give the direction value of 1, which is I6, you give 1. So this counter know that it is going to be a counter down. So you give the input trigger, which is the CNT signal here. And then you see this is the preset value, which is the start value is 5. And then when you press I5, okay, or you give the trigger input to this counter, so it will start decrement the value by 1, okay, until it reach 0. So when it reach 0, then the output will be turned on. Now we move to counter up and down. So when you give the direction of 0, it will be count up, and 1 count down. So we start with the count up first. So we look into the block properties of this counter. So it will be turned on when the value reach 5 and beyond. Okay, and then it will be turned off when the value reach 5 and below. So we start with 10. Okay, so right now the output has been turned on. Okay, because the threshold value is 5. So 10 is greater than 5, so it has been turned on. Okay, we start count up first. So count up, you put the direction as a 0 here. Okay, and then you give the trigger input. Okay, so it will count up. Okay, now we want to start the down, counting down. So we give the input of 1 to this direction. Okay, now the counter knows that it need to count down, and then we start give the trigger signal to this counter by using the same input trigger that we just given to the counting up just now. Okay, so because it is counting down counter now, so the value will be decremented by 1 every time you give the input trigger to the counter until it reach 5. After 5, okay, meaning that when the value is less than 5, because you have set here, it will be off. This output will be turned off when the value is less than 5. Okay, so when the value is 4, the output will be turned off. Okay, so now we change this direction to up counting. So we give the I9 signal here as 1. So now the counter knows that it need to count up. So we start the input trigger. So right now the preset value is 4, meaning that, no, so right now the value is 4, the current value is 4. So when we change the direction to counting up, it will increment this value by 1. So we give the trigger count. Okay, so when the value reach 5, which is the threshold value, so the output will be turned on because you have stated this in your parameter. Okay, so to see whether your output is correctly turned off or turned down, you need to play around with the on and off threshold value at this counter parameter. So hopefully you have so I hope that after this topic, you can understand the function of counter in the PLC programming. It can be counting up or counting down, or it can be both, okay, by changing the direction of up and down at your logo simulation. Okay, because later on, after this class, we are going to start with our example. So I'll see you again in the class and we will do the examples. Okay, thank you and have a nice day.